So I want to go through an example of solving a turbine system to calculate the work coming out of a turbine. So this is an example where we have steam or water in vapor phase coming in at 100 kilograms per minute. It enters the turbine, state 1, and we have a temperature here of 250 degrees Celsius, a pressure of 5 bar. It exits right here at a pressure of 1 bar, and it's a saturated vapor. And we're asked to find out how much work we're producing from this turbine. Well, first thing we need to have is an energy balance that relates to work to the various properties of the materials coming in. And once we have that, then we can go about trying to solve for work. So this is the equation we're going to use to solve for the work coming out of our turbine that we're getting. It's just simply delta H, or the difference in enthalpy between the outlet stream and the inlet stream. And this is the total enthalpy change, but that's also equivalent as the mass flow rate multiplied by the specific enthalpies. And since this is steam, we're in luck that we can look up these values, H2 and H1, from the steam tables. And then we just need to plug the values in to this equation here to solve for the work. So if I pull out my steam tables in the back of the book, this is what I'll get. So these are the values that I get just by looking it up in the back of the book. State 1 is a superheated vapor, comes in at 250 degrees Celsius, 5 bar, so I just look in the appropriate section of the superheated steam section, superheated vapor section, to get this value for the enthalpy coming in. State 2, the outlet to the turbine, comes in at 1 bar saturated vapor, so I look in the saturated liquid section and look up the saturated vapor enthalpy, and I get this. And from here it's very straightforward. I'll just go ahead and solve for work. So just plugging the numbers in, again using the equation up here, taking these numbers, plugging it in. Here we get the equation. This is my final answer, negative 28,600 kilojoules per minute. That's how much work we're producing in this turbine. Let me just point out and remind you again that this is negative, meaning that work is leaving our system. We're doing work on the surroundings, so in other words, we're producing work. It's useful work that we can use outside of the chemicals that are flowing through the system. If we were putting work in, like in a compressor, this would be positive, but it's negative, meaning we are producing work. And this is the general procedure we work with turbines and other type of flow devices. Sometimes we may be given the work and asked to solve for other properties, such as the state coming out of a turbine. We may be giving the work, we may be given state 1, which we can get the enthalpy for state 1, and then have to use this equation right here to find out details about state 2. But again, it all comes down to using this equation right here, the energy balance, and solving for the things that we don't know. Whether that's H2, H1, or work, whatever we don't know, we'll just simply use this equation to solve for it. And that's just it. That's a simple example of solving a turbine to find out how much useful work we're getting out of that turbine.